You ever step outside on a summer day and it just feels heavy and thick? And then on a winter morning, the air feels so sharp and clean? Well, what you're feeling is the same thing that shapes all of our weather. It's the hidden ingredient, the invisible moisture in our atmosphere.
The source material for this explainer just nails it with this line. It perfectly captures this quiet, constant, but incredibly powerful presence of water in the air all around us.
And that's exactly what we're going to do here. We're going to follow the journey of that water from the moment it rises up into the air to when it becomes visible as clouds, and finally how it unleashes the hidden energy that actually drives our weather.
Okay, so let's start at the very beginning. Water's first step into the sky. It's a process we all know, but it is literally the starting point for everything that follows. Evaporation.
Think of the sun as this giant engine, just beaming down energy, warming up oceans, lakes, rivers, even damp soil. All that energy gives water molecules the kick they need to escape and rise up into the atmosphere as a totally invisible gas. It's basically water vapor, just like steam from a kettle, but on a planetary scale. And here's the thing. This is a principle you can actually feel. Warm air is just more energetic. Its molecules are zipping around, they're farther apart, so there's way more room for water vapor to hang out. That is exactly why a hot, humid day feels so muggy. But cold air, it's dense, its molecules are all huddled together, it just can't hold much moisture. And that gives us that crisp, dry feeling of a winter morning.
So we have all this invisible water vapor mixed into the air. How in the world does it become the clouds that we can actually see? Well, the answer is a process called condensation.
You can almost think of it like a recipe, right? A simple four-step recipe for making a cloud. First, you need to lift some moist air. As that air goes higher, it expands and it cools way down. Now, because this cooler air can't hold on to all that vapor anymore, the vapor has to condense back into tiny little liquid droplets. But, and this is the crucial part, it needs something to cling to, a microscopic speck of dust or sea salt or even soot. When billions of these tiny droplets get together, poof, a cloud appears.
And what's so amazing is that this exact same process happens at every single scale you can imagine. It's what makes the mist of your breath on a cold day, it's what creates that thick fog down in a river valley, it's the dew on your lawn in the morning, and it's also the very same process that builds the most gigantic, towering thunderclouds.
Okay, we get how clouds form, but let's get a little more precise. Let's talk about how we actually measure the moisture in the air and pinpoint the exact moment that invisible vapor is forced to become visible.
So how do meteorologists actually quantify all this? How do they put a number on it? Well, the answer is a word you've probably heard 1,000 times on the weather forecast: humidity.
Probably the best way to think of the air is like a big sponge. Relative humidity just tells us how full that sponge is. So if the forecast says 70% relative humidity, it just means the air sponge is 70% full of all the water it could possibly hold at that specific temperature. So what happens when that sponge is totally, completely waterlogged, when it physically cannot hold one more molecule of water vapor? Well, it reaches a point we call saturation. Yep, 100%. At 100% relative humidity, the air is saturated, it's full. And that is the critical tipping point. If that air cools down even just a little bit, condensation has to happen. The sponge has to be wrung out.
And that brings us to the dew point. It's not just a number. It's the exact temperature the air has to cool down to in order to become saturated. This is exactly why you get dew on the grass overnight. The ground gets cold, it cools the air right above it down to its dew point, and suddenly, liquid water appears out of thin air.
But here's where it gets really fascinating. This whole cycle, it isn't just about moving water around. It's about moving energy. And this process is the secret engine that powers our most dramatic weather.
I mean, have you ever really stopped and just looked at a massive thunderstorm and wondered, where does all of that incredible raw power come from? Well, the source has actually been hiding in plain sight the entire time.
That's right. The energy was stored in the invisible water vapor, and the very act of a cloud forming is what unleashes all that power into the atmosphere.
This hidden energy has a name: latent heat. The best analogy is to think of it like a coiled spring. When the sun's heat makes water evaporate, that energy is used to compress the spring, storing all that power inside the water vapor. Later, when that vapor condenses back into a liquid water droplet, that spring is released.
See, it's a two-way street. Evaporation actually absorbs energy, which is why sweating cools you down. It's pulling heat from your skin. But condensation does the exact opposite. It releases all that stored energy back into the air as heat. And it's this sudden, massive release of heat that warms the surrounding air, makes it rise even faster, and becomes the fuel, the engine, that drives the immense power of thunderstorms and hurricanes.
Okay, that's the big global science. Now let's bring it right back down to Earth and see how these principles play out in a real place, using the examples from the northeast of England that our source material mentioned.
This is physics in action, plain and simple. You've got moist air rolling in from the west. It hits the Pennine Hills, and it has nowhere to go but up. As it's forced upward, it cools, it hits its dew point, and bam, it has to drop all its moisture as clouds and rain. Meanwhile, down in the low-lying Riverware Valley, cool, moist air gets trapped on calm nights. It chills down to its dew point, and you wake up to a thick, silent blanket of fog.
So let's just step back for a second and connect all these pieces, and just look at the big picture here. Every single day, the atmosphere is in this constant dance, this constant exchange, trying to balance its budget of water and energy. And all the weather that we see, the dew, the fog, the clouds, the rain, that's just the atmosphere balancing its books right in front of our eyes. So the next time you see clouds gathering or you see mist rising from a field after a rain, remember what you're really looking at. You're watching the breath of our planet. You're seeing water changing its form, energy changing hands, and the weather, quietly, constantly, making itself. Thanks for joining me for this explainer.